Hey guys, welcome back to the series. Today we're going to be learning about polynomials. And some of you might be wondering, what exactly is a polynomial? Basically, a polynomial is an expression that has multiple terms, and they're usually raised to powers like this. So we have 4x cubed plus 2x squared minus 5x plus 6. And there's a few things you want to know about a polynomial. First, you want to know what the leading term is, which would be x. X is the leading term. The leading coefficient is 4. And the degree of the polynomial is 3. This is a third degree polynomial. Whenever you see polynomials, you might hear some of them referred to as binomials and trinomials. Basically, a binomial would be, let's say we just took negative 5x plus 6. That would be a binomial because there are two terms. And then a trinomial would just include 3 terms. So say we include the 2x squared minus 5x plus 6. Now let's get into adding and subtracting polynomials. So say you have 2j to the third minus 14j squared minus 6j plus 25. And we're going to subtract 17j squared plus 11j minus 19. And with this one, it's important to remember that you definitely want to use the distributive property when you're subtracting these. So, this positive 17 becomes a negative, and then this negative 19 will become a positive 19. So what you want to do is begin by combining the like terms. So there are no other j cubes, so we can just go ahead and write that one out. Then you want to combine the j squareds, so you get minus 31 j squared, then 11 or negative 6 minus 11, you get negative 17j. 25 plus 19 gives you 44. And so this will give us our answer. And that is how you add and subtract polynomials. So moving on from there, we want to learn how to multiply polynomials. And this is basically using the FOIL method, but it's expanded, or you could view it as using the distributive property, but using multiple terms. So say we have negative 8y minus 9 times 2y squared minus 8y plus 5. And what you want to do here is you want to break it into multiple parts. So the negative 8y, you will use the distributive property, multiply it by this whole expression. Then you will have the negative 9 and multiply it by the whole expression. So continuing from there, we have negative 16y cubed. Then take the negative 8y times negative 8y, gives us positive 64y squared. And then minus 40y. And then you simply do the same thing for the second. Take negative 9y times 2y squared. That gives you negative 18y squared. Then plus 72y minus 45. And then from there, you can just combine like terms again. So you have negative 16y cubed. You combine the y squareds. That gives you positive 46 y squared. Combine the y's. That gives you positive 32y. And then here's the only constant, so just add that on to the end. And that gives us our answer. Next, I want to introduce you to perfect square trinomials. So say we have x plus 2 squared. Basically saying we are multiplying the same binomial by itself. So what does that give you? Use the FOIL method here. First terms times each other, x squared plus 2x plus 2x, and then our last plus 4. If you simplify that down, it's x squared plus 4x plus 4. And you'll notice here that it starts to take a particular form. So say we have something like x plus a squared. The format this would take is x squared plus 2ax plus a squared. So what does this mean with the original problem we have? This means we have the x squared, and then the 2a would be 2 times 2. So that gives us a 4 here. And then the a squared is simply 2 squared added on at the end. So if you see something like this here, then it will take this format. So you can apply this to any binomial that is squared. Moving on, we have the difference of squares. So say we have x plus 2 times x minus 2. And basically what you're doing here is you're multiplying x plus 2 by its conjugate. So you're just flipping the sign here. If you multiply this out, we have x squared minus 2x plus 2x minus 4. These middle terms cancel out. We have x squared minus 4. So because the middle terms cancel out when you're multiplying the conjugates, in the difference of squares, we can say it takes this form, x plus a times x minus a equals x squared minus a squared. The x is squared at the front, and then constant is squared and subtracted at the end. So let's look at this with multiple variables. Say we have 2 f squared r plus 2r, and you multiply that by negative 3f squared minus 3r plus 8. This works the exact same way. What you can do is you use the distributive property here 2f squared r times this whole expression. It's 3f squared plus 3r plus 8. And then the second term times that whole expression again. Plus 3r plus 8. And then now we simply multiply that out. This time we have an f to the fourth r minus 6 f squared r squared, and multiply it by the last term. You have 16 f squared r. Now we move on to the second part. We have minus 6 f squared r minus 6r squared plus 16r. And now you combine your like terms. We only have one term with f to the fourth r, so go ahead and write that out. Okay, do we have any other f squared r squares? We do not. We do, however, have multiple f squared r terms. So we're going to go ahead and subtract 6f squared r from 16f squared r. So we get positive 10f squared r. Subtract 6r squared and add 16r. Now you could simplify this down further, but for our purposes, we are done. We have successfully multiplied polynomials with multiple variables. So it works basically the same, exactly the same as your normal polynomial multiplication. You use the same process. Anyways, if you found this video helpful, you can go ahead and drop a like if you want, and I'll catch you in the next one.